Okay, this is our Unit 7 review. Let me zoom in and we'll get started. This review will go over everything that we have done so far related to angles and triangles. And we will take our test tomorrow. Let me set up my camera still. Sorry. Hold on, I think that's the best I can get that. Okay, so starting with, we'll call this number 1. The flagpole in the diagram below has a height of 10 feet. So the flagpole's length is 10 feet tall. Okay. The shadow of that flagpole is 12 feet. What is the distance from the top of the flagpole to the end of its shadow? So here's its shadow. This is the pole, so the shadow should be a straight line. It looks like there's a person on the shadow. How cool. 12 feet. Okay, and the question actually asks, what is the distance from the top of the flagpole to the end of its shadow? So top of the flagpole to the end of its shadow, we want to know this distance. Because this is a flagpole going straight up in the air on top of the ground, I know that this will make a 90-degree angle, and that means I have a right triangle. And if I have a right triangle, I can use Pythagorean theorem. Now remember, A, B, and C stand for side lengths of the right triangle, so I can only use Pythagorean theorem for side lengths of right triangles, not with angles. So A and B represent the legs, and C is the hypotenuse. Legs are the angle, or the sides that touch the right angle, so that is going to be 10 and 12. So it doesn't matter which leg you put in for which letter. So I've got 10 squared plus 12 squared equals, and we don't know what the hypotenuse is, C. The hypotenuse can only see the right angle, it doesn't touch it. Okay, that was the first step. The first step was to plug in our numbers. The second step is to add or minus. We're only going to minus if we know what C is. Since I don't know what C is, I don't get to minus, meaning I have to add. So on Desmos, we're typing in 10 squared plus 12 squared. And on Desmos, when you type in 10 squared plus 12 squared, let me pull up Desmos. Okay, so I need to type in 10 squared plus 12 squared, and we'll get 244. 244 tells us C squared. Usually the last step in Pythagorean theorem is to square root. If you take the square root of one side, that gets rid of the square on the other side. That will leave us with just C, and just C represents the side lengths of that from the top of the flagpole to the shadow, which is what we want. If we didn't take the square root, we'd be left with the area of that square, and we're not interested in the area of the square coming off of that. We just want the side length. So we do need to take the square root of 244. And the square root of 244, typing that in, the square root of 244 is 15.6. Remember, the square root button is right here between volume and pi. So we've got 15.6. Now, your answer choices don't actually say 15.6. They say between such and such whole number and other whole number. So think about 15.6 on a number line. If this is 15.6, then the whole number before that was 15, and the whole number after that is 16. And this is a little bit closer to 16 than it is to 15. So we have 15.6. Our answer is between what two whole numbers? Okay. Number 2, will the side lengths 12, 18, and 6 make a right triangle? Well, if I've got a right triangle, I know I can use a squared plus b squared equals c squared for its side lengths. Okay. First step would be to plug in your numbers. So 12, 18, and 6. So I have all three sides. That's great. So this will tell me if it is or is not a right triangle. Remember that the legs are the two shorter sides and the hypotenuse is the longest side. 18 is the longest side, so I'm going to plug that in for the hypotenuse, C. So instead of C, I wrote 18. So instead of C squared, we have 18 squared. Then I'll plug in 12 and 6 for a squared and b squared. Okay. And normally we have to pick whether we add or subtract. We don't have to do that because I know all three numbers. So instead of adding or subtracting, what we're going to do is we're going to see are both sides equal to each other since I know all three numbers. So we'll start by typing in 12 squared plus 6 squared. 12 squared plus 6 squared is 180 equals 18 squared. Whoop, need a new line. That is 324. Those do not equal each other, so this is not a right triangle, meaning I can already get rid of answer A and answer B. So I'm deciding between C and D. Now, looking at letter D, they've got 6 squared plus 18 squared. We have 6 squared plus 12 squared. 18 squared is the hypotenuse, so I shouldn't be adding it with a leg. So this equation is, it's plugged in wrong. Plugged in wrong. Since that's plugged in wrong, it's not going to be my answer. That doesn't explain why it's not a right triangle. What explains why it's not a right triangle would have to be C then, but I'm not sure where 36 and 144 come from. Let me think a little bit. We've got 36, which I know is 6 times 6, which is 6 squared. So it looks like 36 and 144 are coming from the squares of those numbers, and they're adding them together, which is exactly what we should be doing. And does that make 180? Yes, the squares of those numbers added together did make 180. That is not equal to 324 though, so it's not a right triangle. Okay, next we've got surveyors are finding the distance across a lake as shown in the diagram. So the distance across the lake is just this piece right here. Okay, the diagram though has a right triangle. The diagram has this right triangle here. Because I have a right triangle with side lengths, I know I can use a squared plus b squared equals c squared. Okay, the first step would be to plug in my numbers. The right angle is here. Across from the right angle is the hypotenuse because it only sees the right angle. So I can put 82.5 in place of c, but c is squared, so I'm going to square that. Equals the leg squared. Well, 66 is a leg because it's adjacent to the right angle. So I've got 66 squared plus, this is tricky. I've got 24.5, but then I have some length that I don't know, and then I have 2. So the only thing I know about A is it's got to be at least 26 for this whole entire side. But I don't actually know what A is, so I'm going to leave that blank. I can solve for that. After this, we pick add or subtract. We only get to subtract if we know what C is. We only get to add if you know both the numbers touching the plus sign. I know both numbers. I do not know both numbers touching the plus sign. I do know C. So I'm going to subtract. So on Desmos, we're typing in 82.5 minus 66 squared. Sorry, 82.5 squared minus 66 squared is what we're typing in on Desmos. So I've got 82.5 squared minus 66 squared, and that gives me 2,450 and a quarter. 2,450.25. That tells us what the leg squared is. We don't want to know the square that comes off of that side. We just want to know the length. I just want to know the distance, not the area. So I don't need the square. And if I want to get rid of a square, I take the square root of the other side. The usual last step in Pythagorean theorem is to square root. Okay, so now we're typing in the square root of 2,450 and a quarter. And that is 49.5. Is just regular A. Okay, let's think about this before we go and circle that answer. 49.5 represents A, which is the leg of a right triangle. The leg of the right triangle is this entire piece. All of that is 49.5. We already know some of it is 24.5. We know 2. This does not represent only the distance across the lake, and that's what we're asked about. only the distance across the lake is this piece that we don't know. So we want 49.5, but without the stuff that's not on the lake. So we want 49.5 without 24.5, without 2. Mathematically, we say without by subtracting. So 49.5 without the distance above the lake, 24.5. Without the distance below the lake, 2. So we can type that in and we'll find out what just this portion is, and just this portion tells us the distance across the lake, which is our answer. Okay, next question. A right triangle has a hypotenuse measuring 52 inches and a leg measuring 48 inches. What is the measure of the other leg? So this tells me that I don't know the other leg. I want to know the leg. I know I can use a squared plus b squared equals c squared because it says a right triangle. I know I'm missing a leg, so I can leave b squared empty. The hypotenuse is 52. I just have to make sure I know where I'm plugging 52 in. 52 is the hypotenuse, which only sees the right angle. And then one of the legs is 48. Okay. First step was to plug in our numbers, and we've done that. Second step is to add or minus, and we're going to minus because we know what c is. So on our calculator, we're typing in c squared minus the leg squared, so 52 squared minus 48 squared. 52 squared minus 48 squared is 400. So I've got 400 equals c squared, and the last step is to take the square root to get rid of the square. The square root of 400 is 20. Let me type that in and show you. The square root of 400 is 20. Now 20 has no decimal in that number. If there's no decimal in the number, then that means it is at the very end, the very rightmost spot. So that's where the decimal is. That means 0 is right before the decimal and 2 is right before the 0. And everything else can either be blank or zeros. If you had an option to put plus or minus for positive or negative, you'd want to put positive because that's a distance and we can't have negative distance. Okay. The next two problems deal with ordering numbers. So we are done reviewing stuff with Pythagorean theorem for now, and now we're going to pivot into ordering real numbers. To order real numbers on Desmos, there was a little trick for us. We could type in y equals each different number, so the square root of 40. Y equals the square, not the square root. Y equals regular 7. The square root of 40. 7. 15 halves. So the next thing I'll type in is y equals 15 halves. And then the next thing on Desmos I type is y equals 7.2. You need the y equals in front when you're doing this on Desmos because this will then show you a picture. And so instead of making everything decimals and comparing the decimals, we'll have a picture that already puts the numbers in order for us. We just have to know how to read the picture. This one's the list in ascending order, which means we're starting at the bottom and going up. So I want to know those 4 lines in order. So I'm opening up Desmos and I will now type in, so we'd start with y equals the square root of 40. The next number was y equals 7. Then we had y equals 15 over 2. Type the division sign to get the fraction. 15 in the numerator, 2 in the denominator. And then last one, y equals 7.2. Okay, now I'm going on my graph to find the lines, and I'm going to zoom in so that I can see them a little bit better. Okay, the very bottom line is 6.325. It's the red one. The red one is the square root of 40. So our first number on the bottom is the square root of 40. Okay, after that I can delete it And now the bottom line is 7, y equals 7. I'll delete 7. And then we've got 7.2. And then we've got the last number is 15 halves. So in ascending order, we should have the square root of 40, 7, 7.2, 15 halves. Okay. So on the next problem, you can decide which statement is true. Remember, when you have an inequality sign, the open side is the bigger number. So on Desmos, this will be the line that's on the top. On the small side, the pointy side of the inequality is the smaller number. So that's going to be the one that's on the bottom. So you can type in y equals 4 and y equals pi. You can type in y equals pi and then y equals the square root of 9 and compare. Type in y equals 6/5, type in y equals pi, compare. Y equals pi, y equals the square root of 12 minus 7, and compare. Another way you can do this is you can make everything decimals. This would then say for letter A, 4 is larger than about 3.14, which is true. For letter B, this would say 3.14 is smaller than 3. The square root of 9 is 3. That's not true. 3.14 is bigger. Next, we'd have 1.2 is greater than 3.14, which is not true. Then you'd have 3.14 for pi is smaller than about 2.3 or something like that. Anyway, 3 is not smaller than 2, so I know that's not true. Meaning that's our only true. That's our only true response there. Okay. Next, we've got the area of a square tile is 10 inches squared. What is the approximate side length of the square tile? We have talked about if I have the area to get that is the number squared. That is the number squared. How do I know that's the number squared for sure? Because the square comes from, this is the area, that would be the length times the width. But because this shape is a square, I know that those side lengths are the same. So this is just any number times itself, which is a number squared. So I know a number squared is 10. Well, to get rid of the square, we want to take the square root. That'll tell us what just the plain number is, the side length. So we want the square root of 10 for this problem. The square root of 10 is about 3.16. So the approximate side length would be about that length. That goes for the inches also. You have inches squared. If you took the square root of that, you're getting rid of the square on inches as well. So your length is whatever that number was in inches now. Okay, that is the first page of the review. And I'm going to keep the video going, hopefully quickly. Okay, next we've got the diagram shows squares D, E, and F joined at the vertices to form a right triangle. I've got this right triangle here, and I know something about right triangles with missing sides. I know I can use a squared plus b squared equals c squared. Guys, A, B, and C are the side lengths. That means a squared, b squared, and c squared are the areas. So if this is the side length D, then square D represents the area of that leg. Square E represents the area of a leg. Just regular E tells me the side length. Square F tells me the square off of the hypotenuse. Just F is the hypotenuse. Okay, so this is saying for A squared, a leg squared, I can have the area of square D instead of A squared. Instead of B squared, the other leg's square is the area of square E. If we add those together, we should get something that is equal to, off of the hypotenuse we have the square of F. So this will be the area of square F. So you're looking for the answer choice that describes adding square D and square E to equal square F. Letter D says something about equal. Letter C says something about equal. Which one shows us adding square D and square E together to make square F? Okay, next wants to know the approximate distance between point A and point S. On this graph we have point A at 2, 1 and point S at 7, 7. So I want to know the distance between them here. Previously we were finding the slope, which would tell you how steep, or the rate of change, which tells you how this changes over time. We don't want to know how it's changing or how steep this line is. I want to know the length of this line. I want to know how long it is in units. So I'm looking for the distance. So I'm still using the right triangle. I'm still using a right triangle to find the distance here. I don't want to know anything really about those side lengths. What I want to know is the length of this. I need to know those side lengths to help me out though. So this up and down piece is 1, 2, 3, 4, 5, 6 units long. The side to side piece is 1, 2, 3, 4, 5 units long. So what we have is this picture here. A right triangle with 6 and 5. This one's the distance, not the slope. So we are not doing rise over run. Instead, because I have a right triangle and I want to know how long that line is, I want to know its distance, we'll use a squared plus b squared equals c squared. The first step is to plug in your numbers. 6 and 5 represent legs because they're adjacent to the right angle. The question mark is the hypotenuse because it's across from the right angle. It doesn't touch it, it only sees it. So 6 squared plus 5 squared, or 5 squared plus 6 squared, equals c squared. After that, you're picking, do you add or do you minus? Remember, you only minus if you know what c is. We don't know what c is, so we cannot minus, which means we're going to add. When you take 6 squared plus 5 squared, you get 25, 36, 61. 5 squared plus 6 squared, so I'm typing this in on Desmos, is 61. 61 equals c squared. Guys, that's not a square. We don't have the square of that side. We only have its side length. The square would look like this, but we don't have the square. We only have the side length. We don't want squared then. Since we don't want squared, we have to get rid of the square. To get rid of the square, you take the square root of the other side. That's the third step in Pythagorean theorem, usually. So now on my Desmos calculator, we're taking the square root of 61, which is 7.8-ish. Next we have which term best fits in the box labeled A. Just as a reminder, rational numbers are all your positive and negative fractions, decimals that stop, decimals that repeat. Whole numbers is 0 and all of your positive whole numbers. So we're missing some other types of whole numbers that go between them. We're missing positive and negative whole numbers. So we want something that represents positive and negative whole numbers to be between whole and rational. The keyword that describes that is integer. Integers' definitions are positive or negative whole numbers and 0. Imaginary numbers is not even something you learn in 8th grade. So up till now, we don't think that's even real. Natural numbers are just 1, 2, 3, and so on. Only your positive whole numbers, not even 0. So we can't have the natural numbers that have the whole numbers inside of them because 0 is not a natural number. So if we had natural here, that would include 0 since the whole number box is inside of it. So that can't be it. Square roots. Well, that would include something like the square root of 10, which we saw earlier was 3 point blah 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 blah. And if a square root equals a decimal, that's irrational. So if I put all of the square roots in box A, that's going to include some things that are irrational. irrational means it can't be rational, so it shouldn't be in the rational box. So the only answer here that fits is A. Okay. Next, we want to determine the value of x in each diagram. Okay, so remember that we know in 8th grade, when you see stuff like this, let's look for patterns. Mathematicians look for patterns. So I would recommend looking for a pattern first. I'll show you the pattern first, and then I'll show you the math behind the pattern. So x in this diagram is on the outside of the triangle. It's an exterior angle. Okay, it looks like all of your other exterior angles are figured out. Well, to get 120, they did something with 60 and 60. To get 140, they did something with 20 and 120. It appears that they're adding those numbers together to get the exterior angle. They're adding the remote interior angles, opposite interior angles, to get the exterior angle. 35 plus 56, you can use Desmos. 5 and 6 is 11, 3, 5, and 1 is 9. So when you add those together, you do get 91. So the pattern appears to be add the inside opposite angles and you'll get the outside angle. So 130 plus 30 is 160 degrees. Now I will show you mathematically what to do here. Okay, so what we're doing now is we know that triangles have 180 degrees, so 56 plus 35 plus something else should equal 180 degrees, right? So I have 56 plus 35 plus something I don't know is 180 degrees. Well, this is 91 plus the x is 180. So then that missing piece here is going to be the difference between 180 and 91, which is 89. So this angle here is 89 degrees. We know that 89 and 91 now are making a straight line, and straight lines also have 180 degrees. That's true for the other angles as well. When you do this for the 60, 60 blank, you'll get 60 plus 60 plus something. X is, I guess I shouldn't use x, but oh well, is 180. So this added together is 120 plus x equals 180. When you take 120 away from both sides, you'll get x is equal to 60. So this piece here is 60. Now that we know that this angle is 60, we know straight lines also make 180 degrees. 60 and 120 make 180. That's true here as well. When you do 20 plus 120, you get 140. Take away 140 from 180 and you get 40. 40 plus 140 makes 180 degrees, a straight line. So mathematically what's really happening here is we're taking 30, 130, and an angle we don't know. And we're saying, I know that makes a triangle. And triangles have 180 degrees. So 30 and 130 make 160 plus something you don't know. So the missing piece here is 20. The missing inside angle is 20. Now that I know that's 20, I know that straight lines make 180 degrees. If straight lines make 180 degrees, then I know that this piece 20 plus what I have in x, my problem's x, that should add together to make 180. So we should have something that is 20 plus something we don't know equal to 180. When you take 20 away from both sides, you get 160, which is what we found. It's a lot easier if you are looking for patterns when you have diagrams like this. So let's look at the pattern in the next diagram. Instead of using what we know about angles, let's look at the pattern. We've got, we want to know what this number is. This number is like on the opposite side of the line from the other number. Here I've got 113. on the opposite side of the line from another 113. So those things are equal to each other. In the next diagram, we have 127 and 127. Opposite sides of the line, both 127. Here we have a right angle, so 90, and another right angle, 90. Opposite sides of the line, both right angles. So it looks like from the pattern that our numbers should be equal to each other, which means this is 79 degrees. That is the answer. Now I'll show you how we know this mathematically. We learned that angles that are diagonally across from each other are the same. So those 213s are the same, and these two smaller pieces are the same. Then I just copy those same four colors in the bottom of that same line, or same diagram, I mean. So 113, 113, bam. Okay, so everything in yellow is equal to everything in yellow, everything in orange is equal to everything in orange. So you could do that on all four diagrams. And then you're asking yourself, do I have things in the same color or different colors? If they're in the same color, they're congruent, which means they're equal in measure. If they're in different colors, then they're supplementary, which means they add to make 180. Okay, so that is the math behind that answer. However, it is much simpler to look at this and find what is the pattern. Okay, so this is everything we've got for our Unit 7 review. Unit 7 review is going over Pythagorean theorem, problem solving with Pythagorean theorem, so Pythagorean theorem but with an extra step, ordering real numbers, squares and square roots, more Pythagorean theorem, but this time also the area. So if you see a picture like this, it's talking about the areas likely. Okay, distance on a coordinate plane, because it's distance, we're using Pythagorean theorem to help us there. The real number system, and then triangles and parallel lines cut by another line called a transversal, the angles that are formed by that. That is everything that we are reviewing for Unit 7, and we will test tomorrow. If you have any questions, comments, or concerns, please don't hesitate to reach out to me on Schoology, school email, or other methods of contact. Thanks.